You go to configure launch vehicle decom source to open loop telemetry.
Copy LC and work. Vehicle configured for open loop. Did you copy that readback?
I did copy that TLM, and I've got a mark time at 20:06:50. We'll go ahead and check step 351 complete. I want to verify we're receiving nominal launch vehicle open loop telemetry at this time. TLM.
Copy LC. The telemetry receives nominal on the MCC.
Copy that. And see it?
I'll see LCC LV open loop telemetry being received and nominal.
Copy that. See it. We'll check 352 complete. Launch team LC on countdown 1. We're going to make a request. At this time, if you are not critical to the propellant loading operation, please shut down your OCCS VDN screens. Repeat, if you are not critical to the propellant loading operation, please shut down your OCCS VDN screen. And launch team LC countdown, we're currently approaching T-minus 35 minutes to T0. Ops 1 LC step 353, we want to enable the local launch enable button at the failsafe panel and verify local indicators illuminated.
LC Ops 1, launch enabled and illuminated.
And GSO step 354, enable local launch enable button at the failsafe panel and verify your local indicators illuminated.
Launch enabled and illuminated.
Copy that. At this time, we're going to verify RCC enable abort buttons are enabled and illuminated. PM.
Enabled.
RSO.
Enabled.
FSO.
Enabled.
And TD.
TD is enabled.
Copy all there. We'll check 355. Ops 1, verify master global launch enable.
LC Ops 1, master global launch enabled, verified.
LC Elec 1 confirms as well.
Copy that, Elect 1. We'll check 356 and 357. And Ops 1, step 358, you can stop sending ECU commands.
LC Ops 1, ECU commands halted.
Copy that. We'll check 358. Launch team, be advised we're coming up on our final FTS power on and arm command test that will occur at T-minus 30 minutes.
LC, TD on countdown 1.
Go ahead, TD.
Yeah, the range is green for toxic and debris.
Copy. Range is green for toxic and debris. And launch team LC on countdown 1. We're currently at T-minus 30 minutes of counting. At this time, I want to poll for final FTS power on and arm command test. Safety?
Safety is go.
FSO?
FSO go.
Ops 1?
Ops 1 is go.
Elect 2?
Elect 2 is go.
Go to for final FTS power on and arm command test. FSO, step 360. Bring up command transmitter with check channel 1.
FSO in work.
Hi everyone, welcome back to one of my streams again. It's been a long time, a few weeks, I reckon. Yeah, last time was the Soyuz. So yeah, today we had the Antares launching to the ISS. I was just wondering if I should stop the countdown.
WFF-CT site on, check channel radiating.
Roger, FSO. Ops 1, step 361. Apply external power to FTSA and FTSB.
FTSA, external power on. FTSB, external power on.
Okay, they're just powering up the FTS
One,
systems.
FTS external power is nominal.
That's
Roger,
what you're hearing.
One.
And I preferred this stream. I will be switching over to the official NASA stream, although I don't know what they're showing there. Let me have a look. Sorry, I'll drag it into a different screen. Ooh, beautiful shot. Okay, I should hurry up and go to the shots of the rocket. They just showed an engine. Hi everybody. So as you can see, this is my rocket box.
FTSA and FTSB to internal power.
FTSA, internal power on.
And these are a few solar panels from the ISS, but today we have the Antares. Come on.
External power off for FTSA.
This is
and
really
external power off for FTSB.
horrible. Come on, just focus. Behave. Get that into focus, please. Can you get that into focus? Okay, I'm gonna have to do this manually.
Intellect 1, step 365.
Okay.
FTS
I did it manually. Sorry, my face is scanning. It's being dark now.
You go to send FTS receiver arm command for 2 seconds, then remove. Continue check channel. When function removed.
FSO, arm on my mark. 3, 2, 1, mark.
Armed.
+1, +2, arm removed. Check channel continued.
Okay, so we have the Antares today. It's lagging. I hate this. Well, the top fell off. Every time this happens. Let me fix the Antares quick. We need to launch in 20 minutes. We have to fix this. Sir, we're no go. Come on. Attach the Cygnus. I hate when this happens. This never happens until I need to stream. Come on. Where's the magnet? Okay, I attached the magnet in here. I don't know if you can see. And it should connect to the Cygnus and then the Cygnus. This is going to be one of those wonky streams again, isn't it? Well, I'll just leave the Cygnus out. We don't need the Cygnus anyway. Why would you even put a Cygnus on the Antares? I don't understand why you would even put a Cygnus on the Antares. But, well, I know. Oh, I love those little magnets because I can show you this. So, if I don't handle it too roughly. What we have is the Antares, and about 3 minutes after launch, the core stage has burned out, or the center stage, whatever you want to call it. The first stage has burned out. It drops away, and then this is what's left, and then the fairing separates a few seconds later, and then the, come on, I can feel it. You want to, well, this is what's underneath the fairing, and then the interstage will separate, and then this will fall away. This will all drop into the ocean. We'll keep the fish happy. Then this will go into orbit, and then the solid fueled second stage will actually do a sort of flyaway maneuver after it has burned out. They will wait to let it tail off. So if you look at the burn profile, or whatever you want to call it, of a solar motor, it always goes like a sharp peak, then continuous firing, and then depending on what the shape of the fuel inside the rocket is, it goes a little bit up and down, or it can have really a lot of different shapes, but normally it just goes down and then it drops off really quickly, and then there's just a little bit of thrust that goes on for maybe a few minutes. So what they do is actually they wait until they separate, because if they wouldn't, then it will be going into orbit and then it will separate, but then the second stage would continue firing, and it can potentially hit the Cygnus and damage the engine. So what they do is they wait until they are sure it doesn't burn anymore, and then they drop it off. And it does actually, with the reaction control thrusters, it does a maneuver which makes it fly away from the spacecraft, and this usually burns up in a few days. And then the Cygnus will go into orbit. The solar panels will be at the side. I don't have them on because I want to have this model as sort of show what happens when rockets stage and drop their stages. Come on, magnet. Yeah, and if you were wondering what keeps these together, there are some silvery parts in there, and these are the magnets. So yeah, Cygnus is carrying, of course, food and all other stuff to the ISS. And this time they had, for the first time in all of the Cygnus missions, they had a late load, which means they took the top part of the fairing, so they took this part, they took it off, and so they could load cargo into the Cygnus closer to the actual launch, so they could put more fresh food in, so like fruit and these kinds of things, because you want to put them in as late as possible, and also some experiments that are time critical, such as mouse and other animals, sometimes fruit flies too. They want to put them in as close to the launch as possible, so when you can do that just before the rocket goes vertical again, that is the optimal time to put your late load cargo in. That's what they did this time, and the Antares is what I believe from the pre-launch press briefing. Maybe you can correct me on this, Drew, but I don't know for sure. What I understood about the Cygnus is that this one is going to stay up in orbit and test some things after it has left the ISS, and then in October they will launch the second Cygnus, but the first Cygnus is still on orbit, and this is also going to show that they can operate two Cygnuses in space. So that's going to be interesting, having two Cygnuses in space at the same time. Also, the next Cygnus, this one is showing part of the capabilities of the CRS-2 contract, because this launch is still under the first CRS contract, and the second CRS contract, they are going to use the Antares 230 plus, which means they are actually they have the enhanced Cygnus as Cygnus with the enhanced Antares rocket, which is what the most different about the plus version is that the engines are tweaked to have a little bit more thrust, I think, and also the rocket is a little bit stronger, and the interstage between the two fuel tanks, or between the RP1 and liquid oxygen tank, is stronger. And also something with the avionics is going to be different. But what they're going to try and do eventually is run the engines on the first stage at full throttle, because right now they're under throttled, which means they lose a little bit of performance, and it also, it wastes performance. So what they're gonna do is probably stretch the rocket a little bit more and put more fuel in there, so they can run the rocket engine at full thrust. Because if they would run them at full thrust right now, it would basically have too much G-force on the rocket itself. The rocket isn't able to withstand the forces of the engines if they would run them at full throttle. So yeah, but looking at rockets, if you have a rocket and you run it at a lower pressure, also your efficiency, or so your ISP gets lower, which means you get basically less oomph out of your fuel than what you would have got if you would run them at full throttle. So that's what the big difference is here. Let's see if I can switch to the NASA stream. NASA. I should have looked this up before, but I had the website. Yeah, this is much better. Let me unmute this. So
CRS-11, or the first phase of our commercial resupply services contract with NASA.
Hold on.
So our next mission will be CRS-2, and for that we'll be flying a vehicle configuration that we call 230 plus. But what we have here today is a little bit of a hybrid. It's a bit of an upgrade from the 230, just so that we can provide a little more performance. And one of the things that it has available to it is what we call a pop-top fairing. So it allows us to perform a load of cargo later in the flow than we normally would, and actually is able to be performed at the launch pad now.
So tell me about the construction of Antares. About the time do you actually get the call to design an Antares, know when the launch is, and begin the process to start getting ready for an on-time launch?
Sure. So, if you want to go all the way back to the component level, the process of building an Antares actually starts years before we launch. But in terms of integration, a flow would take typically 6 to 9 months from the time that we gather up all of the different assemblies and bring them into our horizontal integration facility at Wallops Island, and start pulling them together into something that you could actually identify as a rocket.
Now, you said this was a little bit of a different configuration. Tell me about the late load process. What was different about this particular launch?
Sure. So one of the unique features of this launch is the cargo late load. So we have built some new electrical and mechanical ground support equipment that allows us to actually take the vehicle from the configuration you see here, where it's vertical at the pad. It can actually convert down back into the horizontal position. We're able to drive what we call a mobile clean room right up to the tip of the fairing, so that we can load time-sensitive research and other perishable items that NASA needs to provide within 24 hours of launch.
And that's a pretty tight turnaround, but there's a critical science that's actually being loaded into Cygnus to accommodate this. One of them is the Rodent Research 12 mission. That'll be arriving at the station, and then, of course, be one of the first actually experiments to come out of Cygnus once it arrives. Images. Now, we have some photos of rollout here. Tell me about the rollout process. Once it's ready to go, what does that look like?
Yeah, so that looks like just a beautiful evening at the eastern shore there for rollout. So you can see that we have some tarps over the top of the fairing there. That just helps keep everything environmentally protected. We've got the transporter erector launcher there that's being used to roll the vehicle from about a mile from our horizontal integration facility out to the pad. That's a slow process. It goes probably about a mile per hour. It's a pretty slow walk for the folks that accompany it out to the pad. And there's another beautiful shot with the the big NASA meatball on the water tower there.
Now, of course, here it is, a live view, again, filling some of that conditioned air. We're now tracking just about 13 minutes from launch. Everything looking good. As you can tell, this is an afternoon launch, a beautiful day, clear skies, just about 54 degrees Fahrenheit, and everything's on track, and we've been counting down these milestones to an on-time launch so far. Now, one of the next milestones that we're looking forward to is a go, no-go poll from Northrop Grumman flight controllers over at Dulles. What are they looking for? What are the things that they're checking from the operations side?
So they're going to be polling folks like our Antares chief engineer, all of the safety officers, and some of the key engineering leads. And those folks are going to be looking at their telemetry data, making sure that the health and the status of the vehicle is all within constraints and that we are ready to go into the final stages of launch today.
Now, of course, after launch, it'll lift off and rendezvous with the station in just over a day and a half. It'll remain there for 3 months until it separates and begins an extended stay. Part of that is some secondary missions, including the deployment of some ThinSats. What are these ThinSats that the Cygnus is going to be deploying?
So I'm glad you asked. The ThinSats are a really cool project. They're a secondary payload on Antares. They'll deploy after Cygnus has been deployed into the orbit. The ThinSats are they're student-led satellites. So they were created by students in 9 different states, actually, and they're going to allow kids to see things like a GPS position, temperature, and just get real telemetry data from space, which is really neat.
And that's an exciting time. Of course, it has the mission to the International Space Station to conduct first, and we'll expect that here on time in just under 12 minutes. At this time, Northrop Grumman has already conducted their go, no-go poll, and from the Northrop Grumman side, we are go.
So you can see the tower has retracted. It is just pulled back
now, again,
slightly.
Part of these milestones is from the go, no-go poll. Just about 5 minutes before launch, the vehicle will switch to internal power, and then we'll begin the initiate auto sequence handout for terminal countdown.
And Ops 2, this is LC on countdown 1, step 394. Your go to start engine evacuation.
LC Ops 2, evac started.
What I think this means is that they are swiveling the engines to test them.
Northrop Grumman flight controllers tracking some of the milestones before we get to that final launch at 3:46 p.m. Central Time today.
Also, something really interesting is that when the Cygnus launches or the Antares launches, it does a path avoidance maneuver just after launch. So what you see is the engines make the rocket do this.
Some exciting scientific
basically power drifts
to the
off
International
the
Space Station here in just about 10 minutes away from launch. Everything tracking from the Northrop Grumman side to be an on-time launch today. One of the investigations going up is a robot called Astro B. This is NASA's next generation of free-flying robots aboard the station. They're self-contained, cube-shaped robots and are designed to help scientists and engineers develop and test technologies for use in microgravity to assist astronauts with routine chores and give ground controllers additional eyes and ears on the space station. Now, these robots, powered by fans and vision-based navigation, perform crew monitoring, sampling, logistics management, and accommodate up to 3 investigations. They can be operated automatically or from the ground. Another investigation are manufacturing fiber optic cables in microgravity. This is called space fibers. This investigation will evaluate a method for producing fiber optic cable from a blend of zirconium, barium, lithium, sodium, and aluminum. This is called Z-blan in space. Z-blan produces glass 100 times more transparent than silica-based glass, exceptional for fiber optics. Microgravity suppresses 2 mechanisms that commonly degrade fiber, and previous studies showed improved properties in fiber drawn in microgravity compared to that fabricated on the ground. The Z-blan fiber is a unique candidate for improved imaging, remote sensing, and next-generation optical communications on Earth due to its low loss and higher bandwidth.
Command's
7
clear.
minutes.
Copy, Elect 1, check 397 and 398.
Today's launches window is by the way is 5 minutes long, but they are.
Bioanalyzer is another experiment from the Canadian Space Agency. This is an instrument that serves as a platform for scientific experiments where astronauts can easily test different body fluids such as blood, saliva, and urine, and get returned key biomedical analyses within a few hours. Scientists will be able to use the bioanalyzer's data to accelerate science experiments. In the future, this type of device could help to keep a closer eye on astronauts' health.
Ooh.
Another
I
experiment
hear some big venting.
This is an image of David St. Jacques, and astronauts show accelerated arterial stiffening during their time in space. These are thicker artery walls and signs associated with the development of insulin resistance after spending 6 months in space. And these dramatic changes in the carotid artery aging was unrecognized until recently. So the vascular aging investigation, this investigation we're seeing here,
but
will include
I don't know.
investigations to test the relationship
Doesn't he?
among a crew member's metabolism, aging arteries, and aging bones. The results of this study could have great importance for assessing a newly identified risk for astronaut cardiovascular health, potentially pointing to mechanisms to reduce risk.
So also we have a 5-minute window today.
And these are again just a few of the more than 3,400 pounds of science currently loaded on board Northrop Grumman's CRS-11 Cygnus vehicle, now under 7 minutes from launch.
So the 5-minute window is built around the optimal time, which is
closed, and OCCS is in automatic control mode.
Halfway in the time.
And a copy, Prop 1.
So they had 3 slots to launch.
VTSO activation verified.
Roger that. Check 402, Ops 2, 403, initialize ground ordnance power supplies.
LC, Ops 2, ground ordnance power supplies initialized.
LC Elect 1, ground ordnance power supplies.
Hello, more people joining. I love that. I will never be as big as every astronaut, but getting there. Slowly. Anyway, watch out for the pad avoidance maneuver that the Antares does. I can actually show you with the Antares itself. Come on. Go to... Be a good boy.
LC site control, FA ECS transfer to GN2 is confirmed.
Copy that, site control. We'll check 405 complete.
So Gary, you can see right now that the top half of the first stage is really very cold with that cryogenic liquid oxygen. The Antares logo that you would normally see running down the side there is completely obscured by ice, and we've got the sort of evaporative process happening on the liquid oxygen boiling off of its relief valves and vent valves there.
It is 60. It is 46 because 2 hours because of daylight savings time. UTC doesn't change.
And Ops 2, your go for step 406, initiate engine priming.
Priming started.
Ops 1, you go to transfer avionics to internal power.
LC Ops 1, avionics internal power on, standby 5.
So what the pad avoidance maneuver does, or the Antares does, is actually, this is the launch tower.
You hear those calls, the vehicle
and the pad underneath. Ooh, don't fall apart. It does swivel like this, and then goes back, so it power drifts off the pad, which is pretty cool. You watch out for that. And also, what's special about the Antares?
FTLU and FTS receiver indications are nominal.
Copy Elect 2, we'll check 410. Ops 1, step 411, you go to send all arm command.
Ops 1, all arm command sent.
I will just wait. What's special about the Antares is...
Elect 1, SNAs, ODMs, all armed.
Copy Elect 1. NASA TD, report range status.
Range is green.
Range is green.
Copy, range is green.
So the special thing about the Antares is that, of course, the liquid stage and then solid stage combination, but what I find really weird.
LC MES1, Priming verified, MES1.
Copy, priming verified, check 414.
is that the Antares goes up and then
And launch team phase 3 dynamic limits will be active at T-minus 3 minutes.
goes to the Grumman line, and then basically MECO happens, and then the interstage plus fairing separates. They wait a few seconds, then separate the fairing, and then drop the interstage, and then ignite the second stage, which normally you would see
FC command into flight mode.
a rocket ignite its second stage before it drops its fairings, or it drops its fairings while being still
3
under
minutes
power
before
of the
launch, we're now in
first
the
stage.
terminal count until launch on time, 3:46 p.m. Central Time.
Can you expect another launch of a rocket attack? Yes, you can.
Roger, Elec 1.
I
Step 420, verify ready for nav mode.
finished the script of the Ariane 5, so
Ops 2, step 421, switch to nav.
Or
I-
nav to navigate.
LC nav. Or nav to verify.
Copy that nav, we'll check 422 complete.
I had time to record it 2 weeks ago, but then my voice was basically shit, so that's what happened. I have a holiday coming up, so maybe I will even record it tomorrow and you will have it by the weekend, which is really optimistic, but
And T-minus 2 minutes on my mark. Mark.
too much 2 minutes. So really optimistic, but maybe this weekend you can
Now
expect
under 2
the
minutes
second
for launch,
episode
everything's
in
still
Rocket
looking
Talk.
good during this automatic countdown.
Hopefully there are no
T-minus
boats.
30, T-minus 1 minute, 30 seconds on my mark.
Mark. I can call it out. I know exactly when the time. Ooh. It's funny. Let's go to space today. So this Cygnus will stay up and be up when the next Cygnus launches
And
in
T-minus
October.
1 minute on my mark.
Mark. Knowing the exact time to the second is
Now
so
under
funny.
a minute to launch in just about 10 seconds, then tanks will be pressurized. Everything's still on track for a liftoff on time.
Let's go. T-minus.
T-minus 30
Just
seconds.
30. T-minus 20.
T-minus
T-minus
10.
10. 9. 8. 7. 6. 5.
4,
3.
2,
2.
1.
1. Ignition.
And we have engine ignition.
Liftoff. It's so
And we have
cool.
liftoff of the Antares NG-11
CD pad
mission.
avoidance
Advance
maneuver.
engines
That's
full
what I
power.
meant.
Attitude is nominal. Core pressurization looks good. Power systems look good.
Woo.
Stable operation, full power, both engines.
Yes.
Core pressures look solid. Attitude is nominal.
Are we gonna have?
C is nominal.
Oh yeah, that's what I remembered.
Power systems look good. Engines remain at full thrust, operating nominally.
Everything looking good during this first stage burn. It burns
Altitude
for
passes
3 minutes
10,000
35
feet.
seconds.
Throttling back to 55% power.
They call out so much nominal so much times in this. There's even a meme / regular video,
Nominal operation at 55% power.
and during.
Throttling back up to full power.
Oh,
Engines
wow,
are back
that's
to full power.
beautiful.
TPC remains nominal.
That's actually so bright it blacks out the
Attitude nominal,
camera,
dispatch
which is
at
really
T plus
cool.
60 seconds.
But they
Altitude passes 25,000 feet.
they said everything was
Attitude
nominal
transonic.
91 times, so figure.
Attitude is nominal. Engines continue to operate at full power.
Everything looking good. About 10 more seconds of this first stage burn.
With nominal attitude, pass through 40,000 feet altitude. Engines remain nominal, full power. Fuel pressurization is nominal. VNG3 is on.
Ooh.
Altitude past 50,000 feet.
No, it's not.
Engines remain nominal. Attitude and power systems all look good.
I hope we get to see Miko and fairing separation, which should be awesome.
Operate nominally at 100% power. TVC steering, power systems.
2 minutes into the flight, 1 minute 30 seconds until this main engine cut off.
Passing through 100,000 feet. Power systems remain nominal. Attitude is good.
Ooh.
Engines continue to operate at full power.
I love these images. They're beautiful. So watch out for stage separation, which is going to be
power systems are good.
Happening is this.
Is
this is what's going to separate from the first stage.
Core pressures look nominal. Approximately 1 minute till main engine cutoff. Engine power is nominal. Attitude is nominal. Avionics power is good. We're starting our slow throttle ramp for G limiting.
So what you're doing is keeping the G load around 4 Gs. So that's what they do. They throttle the engines to keep it at 4 G of acceleration.
Engines are throttled back to 55.
About 30 more seconds of this burn. Main engine will cut off. Stage 1 will separate, and the vehicle will coast for just a bit before fairing separation.
Engine operation at 55% power is nominal. TVC slew for main engine cutoff has started.
So what that means is the
engine operation continues to be nominal.
Just before main engine cutoff, the engines are not allowed to
and we have main engine cutoff.
Steer the rocket anymore.
So nominal post shutdown.
They don't have a spin while cutting off. Stage 1 separation.
ACS performance is nominal.
And then
Stage 2 ignition will be in approximately 30 seconds.
Fairing separation.
Again, this is a coast period.
Antares is now coasting in preparation for Stage 2 ignition.
Don't we get to
Stage
see the
1 Delta V was
graphics?
17,348 feet per second. Altitude is 130 kilometers. Interstage SEP.
Interstage
Attitude
SEP.
remains nominal. TVC batteries initiated. And we have Stage 2 ignition.
Yay! Stage 2 is now powering the Antares into the Cygnus into orbit.
The 30 XL motor will burn for approximately 2.5 minutes. Attitude is nominal. Motor pressure is nominal at approximately 100 psi. Power systems look good.
Bummer we don't get to see
the TVC is nominal. And attitude remains nominal.
Everything looking good. The fairing has been separating. Cygnus is now revealed in the inner stage at the back of the vehicle, separated before Stage 2 ignition.
Attitude remains nominal. Avionics power systems and temperatures all look good.
Again, this is solid rocket fuel.
This is what's left now of the Antares. So we basically burned this, dropped it away, didn't need the fairing anymore, dropped it away. This is what's left.
Velocity is now 5 kilometers per second. Capture 30 burn continues. Motor pressure is 775 psi. Attitude remains nominal. All systems look good at this point. Avionics power looks nominal. Attitude is nominal. Just minor activity from the Stage 2 attitude control system during the motor burn.
That's good. That's a good signature.
TVC is nominal. Power is good. Motor pressure is now approximately 685 psi. Velocity 6 kilometers per second. Attitude is nominal.
Solar
Altitude
grain
200
is
kilometers.
increasing
Stage 2
the
TVC looks good.
pressure. That's not what it looks like.
Slow tail off now, dropping below 500 psi. TVC remains nominal.
Someone forgot to
Power is
stage.
good.
Japnet needs to hit
7 kilometers per
spacebar.
second velocity. Attitude is nominal.
Well,
Altitude is 205 kilometers. And we have stage 2 motor burnout.
burnout,
We'll
yes.
now coast for approximately 2 minutes prior to Cygnus spacecraft separation.
This guy normal. Look at what they're showing us. They're showing us the complete Antares, which is
Attitude is nominal.
yes. The Russians even have better
All
animations
systems look
than.
good. Second stage attitude control system is starting to reorient the vehicle for payload separation.
I don't understand.
Nominal.
Why is this so messed up? They've done this like
Loss of signal on motor cone and
11 times before.
All systems look good. We're just standing by for Cygnus spacecraft separation.
So according to the image, they put the whole Antares into orbit, which isn't supposed to happen.
And all systems look
Only
green.
this part of the Antares reaches orbit,
Attitude all look nominal as we come up on mission time.
and this drops
T plus
away. But
490 seconds. Vehicle is now oriented for spacecraft separation. Attitude is nominal.
Yeah, Gary, it looks like our telemetry is a little unusual here. I think we're showing a bit of a stale vehicle graphic here. At this point, we've got the stage 2, the capsule.
too much orbital debris. Yeah.
With the Cygnus payload still attached, coasting and ready for deployment. So imagine that instead of what we're showing here.
So this coast is, like I already explained.
Sounds good, and just about 9 minutes after liftoff, we should be expecting Cygnus separation.
Like I explained, they wait for the thrust to tail off because every time you have ignite a solar engine, the thrust. Ooh, we have spacecraft separation. Bloop. There we go. Drop the second stage. We don't need it anymore. This is now on its way to the ISS.
Antares is reorienting for the collision and contamination avoidance maneuver. Insertion orbit looks nominal.
Yeah. It was funny. Wow. Let's
mission
see.
is complete. Initial results all look nominal, and we're signing off from the LCC.
Yes.
Launch control reporting a good ascent of the Cygnus vehicle on top of the Antares rocket, carrying it on its 9-minute journey into an orbital insertion. 7,600 pounds of cargo inside will make its way to the International Space Station over the next day and a half, ready to rendezvous with the station Friday at 4:30 a.m. Central Time.
loss of signal on the avionics link.
A series of a few milestones before we get to that point. There'll be a series of a few burns over the next about 2 hours before we begin solar array deploy.
Oh,
These are the 2 ultraflex solar arrays that are on the back of the Cygnus vehicle. Join us for our live coverage of that event at 6 p.m. Central Time tonight.
Wait, they don't deploy the solar relays for 2
Northrop Grumman
hours?
flight controllers you see here at the Mission Control Center in Dulles will be monitoring the vehicle over the next day and a half, overseeing all the milestones throughout its journey to the International Space Station. A good ascent of the Cygnus cargo vehicle and 7,600 pounds into orbit. Again, we'll be back on in just about 2 hours. 6 p.m. Central Time, 7 p.m. Eastern for our coverage of the solar array deploy.
Yeah, 4:30.
We'll conclude coverage and then come back for a capture on Friday, April 19th, scheduled for 4:30 a.m. Central Time. Again, Ann McClain aboard the International Space Station will be the prime robotics operator to grab that vehicle using the station's robotic arm to feed St. Jacques, backing her up, and Nick Hague monitoring telemetry. A good ascent of Cygnus into orbit over a 9-minute journey. Again, we'll be back in the next 2 hours. This is Mission Control Houston.
Yes, so let me mute this and switch over. So yeah, that was the Antares, which is interesting. I don't really understand why they wait 2 hours to deploy solar panels, because normally you want power as soon as possible, but I also think yeah, but sometimes with GEO satellites they partly deploy the solar panels, and once they are in their orbital slot they fully deploy their panels, which is, I don't understand why, because from what I understand you just want to deploy your solar arrays immediately. So yeah, I don't really understand why wouldn't you, why would you wait until 2 hours? It drains part of your battery, so I don't really know why you want to get low on battery. You want to recharge it as quickly as possible, but I'm not a rocket engineer, so I guess I don't know enough about this. So yeah, are there any questions left in the chat room? Otherwise, I'm gonna round this off, and you'll probably, the next thing you'll see from me is a Rocket Talk episode. What's connecting and disconnecting? My mouse is giving me certainly. It's annoying. I was drawing another model the other day, and then it just was disconnecting all the time. So yeah, if there are no questions left, yeah, so it's gonna take 1.5 days to get there. And interesting idea. No, I don't have a Cygnus ready. I was wondering if I should live stream the approach with my model, my ISS model, like show you approaching the ISS in real time on my model and then moving the Cygnus closer every time. But I think that's not doable. So no, my ISS is in pieces anyway. So yeah, interesting. We had a successful launch of the ISS, or of the ISS. Wow, it's getting late. We had a successful launch of the Cygnus to the ISS. The Antares performed absolutely fine. We'll see if it arrives to the ISS in a few days. Actually, Friday afternoon, I believe. We still have to wait until it deploys its solar panels before it can continue its mission, but we'll see. And until next launch, this was me, and yeah, follow me on Twitter for more models like these, and my Twitter's in the description. And if you like what I do and you want to support me, please support me on Patreon. I do have a Patreon page. And yeah, thanks for watching. See you in the next one. I'm out at Astra to the stars.